So the starting point for every straight line is a line that has a slope of 1 and it goes through 0, 0, okay? And that one will always be labeled as f of x, the function of x. This is the first line. You can think of f as the first line, right? Now the equation, to write the equation of any line, we need m, we need b. So the equation of this line would be y equals 1x plus 0. Obviously, they're not going to put plus 0 on the STAR test. So you can also think of it as y is equal to x. In theory, this looks very simple, but on the STAR test, they have started writing these equations in function notation form. What is function notation? Something that we learned when Miss Lovelace was not here. Function notation, what they're going to do is they're going to switch that y equals to an f of x. So this equation here, the way it would look is f of x is equal to x. Confusing. But the linear parent function can be transformed or changed by adding or subtracting values to the function or its input values. The first transformation that we're going to look at is adding or subtracting a number at the end of the equation, plus or minus d. When you change this or when you transform this, what it's actually going to do is it's going to change the y-intercept. If you're changing the y-intercept, what are you doing to the line? You're moving it in what direction?
Right.
If you're changing the y-intercept,
the
y-intercept, you are moving it up and down. So that's what we're going to look at first.
What? On y.
You're moving it up and down.
Are you recording?
I am recording.
Oh.
So what is on the video? So that means you are translating it vertically.
Miss, that looked like you were moving the line left to right.
It does look like you're moving it left to right, and moving it left to right is what we're going to do on the back side. Okay? So we're moving it vertically. Now, when we move the line up, you would be adding. So that would shift it up. And moving it down subtracts. Okay? Now, looking at the equation in this form right here is very confusing because it has f of x, it has d. We've never seen those variables, or we're not used to seeing those. So what I've gotten in the habit of getting my students to do, or getting all students to do, is to change it back to slope-intercept form. So this equation, what it would look like normally is y is equal to x plus d. You've seen an equation that looks similar to x plus d in the form of y equals mx plus b. So you'll notice that b and d are in the same spot. B and d act the same. D is like the y-intercept. It's not exactly the y-intercept, but it's like it. So when you're changing the y-intercept, you're moving the line up and down, okay? So for numbers 1 and 2, they want you to describe how the functions of numbers 1 and 2 relate to the parent function. Compare it to the parent function. Then we're not going to graph it, okay? So looking at it, the equation in this form is very confusing. So the way to make it easier to understand or easier to look at is to switch it back to quote unquote slope-intercept form. So g of x is the same as having y equals. F of x will switch back to an x plus 6. This is an equation that I'm used to seeing. You want to compare that to the parent function. The parent function is y is equal to x, or 1x plus 0. What is the difference between those two equations? The plus 6. Okay? What did the plus 6 do to my graph? If it started off as plus 0 and it changed to a plus 6, it moved up. And then on the STAR test, they use the word shift. So it shifts up 6 units. When I say units, I'm talking about the boxes on your graph, okay? It moves up 6 boxes, but they're not going to say boxes, obviously, okay? Number 2. Switch function notation form back to slope-intercept to make it easier to describe, to make it easier to look at. H of x is the same as having a yx. F of x is just x minus 5. So, from the parent function to this one, what changed? The minus 5. And the minus 5 does what to the line?
Down 5.
It shifts down 5 units. Shifts down 5 units. Every transformation will always be compared to f of x equals x or y equals x, okay? You're always going to compare it to that because that is your starting point. Numbers 3 through 5. Usually at this point, by this point, a student will ask me, why do we even have G, H, F, K, element of P, whatever, right? Well, the reason we have that is, don't write this down.
To confuse people.
Honestly, it's not to confuse you. It's to separate or to label the lines. That way, if I tell you, take the function of f of x and transform it to create p. That way you know I'm talking about this line instead of this line, right? They're just labels. If I tell you to do something to line M, you know I'm talking about this line and not this one. They are names for the lines. So you're able to distinguish, or so you're able to see what line I'm talking about. Because if these were all, imagine if they were all y equals. Would you know what line you're supposed to mess with? No. So all those letters, they're just names, okay? All right, so let's look at number 3. Luis graph g of x is equal to f of x minus 4. I can't, and it says label his line. I can't tell you which one is his line is just by looking at that equation. I must switch it back to slope-intercept form. So g of x switches back to y equals. F of x switches to x. Look at f of x and x are equal, so you just switch it back, okay? F of x switches to x, bring down the minus 4. So which one of those lines is y is equal to x minus 4? Top, middle, bottom? The bottom one. So now I know that the bottom line is my g of x. This is Luis's line. And how was Luis's line changed from the parent function? It shifted down. It went down 4 units, so it shifted down 4 units. Okay. Now it says Cora graph the second line. There's only one other line that's not labeled, so we're going to label that one for Cora. That one's h of x. Okay. It says label her line and then write the equation of that line. They want us to write it in function notation form though. Okay. To write the equation of any line, you need the slope, you need the y-intercept. The slope of the line, did it change? No, the slope is what? Up 1 over 1, 1. What's the new y-intercept? 4. So if I write this in slope-intercept form, I would write it as y equals 4. But because on the STAR test, they now require us to write it this way, we must make some changes. Y is going to change to h of x. X switches out with f of x. Bring down the plus 4. Okay. Look at, or number 5. It says, how do the slopes and the y-intercepts compare? What happened to the slope? Did anything happen to the slope? No. The slope stayed the same. Look at what happens. Look at the board. If anything happens to the slope, what's going to happen to the line? It makes it steeper. Or what else can you do to say to describe that? What's happening to the line?
It's getting more vertical.
more vertical, we can say that it is what? Rotating, yeah? Did these lines rotate? No, they didn't tilt in any way. The tilt of the line didn't change in any way. So the slope didn't change. What changed is that it moved altogether up or altogether down, okay? So it's just a shift. Slope stays the same slope, different y-intercept. And because there's a different y-intercept, we call that the shift, okay? Number 6. Given that f of x equals x, Sophia is going to graph this function. Well, in order to describe what happened or the changes that were made, I need to switch it back to slope-intercept form. So let's switch it back. P of x will change to y equals f of x changes to minus 2. It says describe the changes in the slope. What happened to the slope? Nothing. Same slope. What happened to the y-intercept? How? Shifted down 2. So, long story short, if you change the y-intercept, you're shifting up or down. Up if you add, down if you subtract. Yes? Okay. Another thing, today we're not going to mess with the slope at all. On your assignment, some of those questions are going to be describing what did you do to the slope. You didn't do anything. We're not messing with the slope today. Flip it over.
Yes.
Now, the way that the function is written on the back, you'll notice that x is inside parentheses. We've done this with, actually you haven't seen anything written this way, okay? You haven't seen any type of equation written this way, but when they group the x with c, this is a transformation of the x-intercept. And if you're changing the x-intercept, what direction would you be moving the line in? Left and right. Changing the x-intercept changes the left and right. But think about, because there's a minus here, think about your point slope form. This is going to be the opposite, okay? It only changes to a plus sign if you plug in a negative number. But if you plug in a positive, it stays as a minus sign, okay? When f of x is transformed by f of x minus c, the linear function shifts or is translated horizontally. Or it is translated horizontally, okay? So once again, because of this minus sign, you have to think of the number that is plugged in as opposite. Think opposite, okay? So what type of number did you have to plug in order to change it to a plus sign? A negative number. And because you plugged in the negative number, which way did it move the line?
Down. Up.
Left.
Left.
Left. Okay? What kind of number did you have to plug in for it to stay as a minus sign? A positive number, and a positive number will move it to the right. Okay? So, number inside of the parentheses moves it left and right. Number outside of the parentheses moves it up and down. Got it? Outside parentheses, up and down. Inside parentheses, left and right. Okay? Let's look at 7. In order to describe what happens to this line, let's switch it back. So, f of x switches back to y equals. And then from there, just take the f off. To go from slope intercept to function notation, all they do is add that f. So to go back, take the f off. That's it. Okay? Now, because it stayed as a minus sign, That means what kind of 1 was plugged in? Positive. And a positive 1 is going to move to the right. So this one shifts right 1 unit. It shifts to the right 1 unit. They want us to end up graphing this as well. So what we're going to do, this is my parent function, my first line, my f of x. What you're doing here is you're literally taking the y-intercept or the origin, moving it over 1. You're taking every single point, moving it over by 1, moving it to the right 1. And this becomes your new line. And yes, it is parallel, correct. I'm going to label this with m of x. That's my m of x line.
I'm locked in, miss.
No, you're not. You're not even writing anything.
I am. It's just I can't see the first thing because you already moved it.
But you can see the graph that you should be copying as well.
You already copied the graph.
All right. Let's look at number 8. Switch it back to slope-intercept form so you can know what to do.
Can you widen it?
R of x changes back to,
Y equals
take the f off, 7. Now, what kind of 7 did you have to plug in for it to change to a plus sign? A -7. So a negative number is going to move this line to the left. So to graph this line, I start at the origin and move it 7 units to the left. Every single point from that line moves 7 units to the left. So this point moves 7 units to the left. This point moves 7 units to the left. Every single point moves 7 units to the left. And that is line R of x. Okay. Number 10 through 12. Everybody got it? Yeah. No? Yes. All right. So, number 10. Camila graphed g of x is f of x minus 5. I know it's not the middle line because the middle line is my parent function. But to know which one of the other two it is, I need to switch it back to slope-intercept form. G of x switches back to y equals, take f off, and leave the x minus 5. Okay? So, in order for it to stay as a minus sign, what would my x-intercept be? A positive 5. So this is actually which line? Top, middle, bottom. The bottom one. So this bottom line is my g of x. This is Camila's line. Which way did we shift this one? To the right. Shifted to the right 5 units. Shifted to the right 5 units. Now it says on number 11, Ike is the one that graphed the second line. Ike's line is h of x. Okay. We need to write the equation of Ike's line. The new x-intercept of Ike's line is what? Okay, so that tells me, I'm going to write it in slope-intercept form first. If I plug in a -5, what's going to happen? It's going to change to a plus sign. Plugging in a negative where there should be a minus sign, 2 negatives make a positive, okay? So to switch it to function notation form, what's the difference? What do I need to include with that? put an F in the front. Okay? Please don't ask me why they chose to write it the way they did. That's just how it's done.
Why did they choose to write it the way they did?
Number 12, how do the slopes and the x-intercepts of the students' lines compare? What happened to the slope? Nothing. Same slope. And everything we do, we're not changing the slope today. We will tomorrow. What happened to the x-intercept? Those change. Shifted left or right. Okay? Left or right. If it's shifted to the left, you get x plus c. If it shifts to the right, you get x minus c. Or if you don't want to use c, use the number sign. X plus the number. X minus the number. Okay? Number 13. Which one's my parent function, G or F? F is always the parent function. Your starting point is always F. Okay? We're trying to compare this one to the new one, right? So it says it was shifted horizontally to create the function of G. Which way did we shift this horizontally? To the left. And the new x-intercept is -3. No, not yet. The new x-intercept is -3, right? Now, when you write this in slope-intercept form, you would write it as x minus. Then you plug in your -3. Are you with me so far? Okay, but plugging in a -3 is going to cause what the inside of the parentheses to change to a plus sign. Okay, still with me? But on the STAR test, they don't write it that way. We can't use y equals. We now have to use, instead of y equals, it will be G. This one is G. It will always tell you what letter to use. And in this case, we're using letter G. Okay? So y equals changes to G of x. And then in front of the parentheses, put an F. That's how your answer choice will look like. Yes. That's why, to make your life easier, you have to know how to go from here to here. Okay? Always, it's going to make your life a whole lot easier if you start off writing it this way first, then switching the letters out. Okay? All right, number 14, last one. We want to compare the parent function, f of x equals x, to the new one. Now, the new one is written the confusing way, function notation. So let's switch it back. A of x switches back to y equals, and when we go back to y equals form, what do we do with the f? Just get rid of it.
Get rid of that junk.
Okay? Now, now that we can look at this equation, did we do anything to the slope? No. Same slope. What is the slope? Yeah. If you don't change the slope, it's going to be a 1. But a -9 tells me that the x-intercept is what? Positive 90.
Stop.
And a positive 90 will shift my line which way? It shifts it to the right 9 units. Shifts it to the right 9 units. Okay? So, we looked at two different numbers. I'm just going to write it in y equals form. Hold on, I didn't mean to put plus, minus. Okay? Number, that's just a symbol for a number sign before you guys decided to turn it into a hashtag. All right, number inside of the parentheses moves it what? Left and right. Number outside of the parentheses moves it up and down. Okay? Inside of the parentheses, moves it left and right. Outside of the parentheses, moves it up and down. Inside of the parentheses, opposite. Okay? Oops, sorry. I was trying to...